Hi, welcome back to the MemSQL Developer live stream. Today we're going to get our content into containers. Now we do have a Docker Compose file that gets us started in that direction, but let's get both the app and the API in containers as well. Grab the code at github.com/robrich and go grab the MemSQL example architecture app to get started. So let's dive in. We want to first create content in our API. So I'm going to say new file. Let's create a .docker ignore file. This is everything that we don't want to end up in our container. So .vs code, the dist folder, node modules. We're going to rebuild the app inside the container. We don't want package lock.json. We don't want .git ignore. And that's interesting. This format looks a lot like the .gitignore file. And in fact, it is exactly the same syntax. If Docker doesn't find a .gitignore file, then it will use, or if it doesn't find the Docker ignore file, it will use the gitignore file as well. Looks like I missed .env. We definitely don't want our developer settings to end up in the container. Okay, that's everything that won't copy into place. Now let's talk about all of the files that will get copied into place and the content that we want to build to make that happen. Now this is Dockerfile, not dockerfile.txt. Now that we have that Docker file from node alpine. The alpine image is a little bit smaller Linux kernel, so ultimately that node container will be so much smaller than if we were just to use regular node. I got this from Docker Hub. hub.docker.com will get us there. So we want to copy in all of our content. This is the outside directory, the directory on our host machine, and we're going to copy it into the current directory inside the container. We'll set this outside directory as we launch the docker build command. This inside directory, let's set that now. Workdir is /src. Okay, so we're going to copy all the content into place. We will run npm install, and we'll run npm test, and we'll run npm build. npm build will dump our content to the dist folder. Now we don't have any tests in this case, so let's comment this out. Now, if I change any of my source code, it will invalidate this layer. Each of these commands is a separate layer in our container. And then it'll reinstall all of our npm packages. I probably don't want to reinstall all my npm packages if I'm just changing an HTML file. So let's do that first. But next we need to know, how do we install that content? So let's copy in our manifest, package.json, into the current folder, this /source directory. So we'll copy our content, we'll install, then we'll copy everything else that wasn't excluded in the Docker ignore file. We'll run our tests, we'll build, and then let's set our workdir to /app, and we'll copy our content. Well, in this case, we'll run copy from /src/dist to the current folder, and cmd, the command that will run as the container starts up, we want to say node index.js. Okay, now this would work just fine, but my source code and my build tools are installed in my container, which makes it a little bit bigger than what I would expect. Let's prune that down a little bit. Run npm run, or npm prune -- production. And I have in my package.json a GitHub dependency. So I do need Git in here as well. Now this is Alpine Linux, not Ubuntu, so I can't just say run apt-get install git. Instead, here in Alpine, it is apk add git. And I'll do the apk upgrade, apk update before I run that, just to make sure that I have the latest version of all the packages. apk update and apk add git, then set my work directory, copy in my manifest, install all my dependencies, copy and everything else, test, build, prune, not product, production, prune the packages down to just those things I need in production. And now let's start a new container that only includes the built content, not all the source code. From node alpine. This will be our production runtime container. Now, instead of copying that way, let's copy, and we don't want to copy from our host file system. Let's say -- from equals build. Now this build section, how do we name this as, how do we name the build section? Well, up here, let's call this one the build server, build container. And we'll just name it as build. Now we're doing exactly that. We have this top section that will do the building and this bottom section that only includes those pieces that we need to be able to run our app. Let's also copy from equals build source node modules to app node modules. Since we don't have all those node modules from over here, let's copy those into place as well. Now with this API, we have set a bunch of environment variables. Here's the port environment variable that tells it what port to launch on. Here's a bunch of environment variables that tell us how to connect to our database. So let's go grab a bunch of environment variables. Now here in the Docker file, we'll paste them here into the runtime, the production runtime container, and this specifies defaults. Now we may choose to change these defaults in time. Probably we don't want to default this to memSQL. Probably we don't want to default this to username. But for now, for this experiment, just to make it easier to start up later, let's just leave them there. That's awesome. Now this production, in our package JSON, we include TypeScript as a dev dependency, but as we build it, it has this dependency on tslib. So let's go install tslib, cd API, npm install tslib. And tslib then, as a production runtime dependency, will allow us to run that TypeScript. Perfect. We've got our Docker file ready to go. We have our Docker ignore file that tells us those things we don't want to build into place. Let's build it. Docker build -t will tag it straight away as API version 0.1, and we'll give it that current folder, that outside folder. In this case, that dot says the current directory, the one that we're in right now. So we'll go update all the things, pull in Git, pull in our npm dependencies. There's a few things that we can probably remove in time. Here's our npm dependencies. We've got our npm dependencies in place. Now let's do copy and everything else, and we'll do our npm run build. Oh, npm build. I didn't say, let me try that again. It's not npm build, it's npm run build. And this would be npm run test. Okay, let's start this again. Docker build -t API v0.1 dot. Okay, so it used all of the npm dependencies before, and now we'll just start with doing that TypeScript build. There's our TypeScript build, the prune, set all the environment variables, Docker image list, and we see that we've got this image built straight away. Here's our API image, and it is 120 megs. Now we did do this build image, here's that none, and it's 215 megs. We don't need all of that weight in our application, but still, 120 megs for an entire machine? That's not bad. Okay, so we've got our file for API. Let's copy that into place for our app. Docker file and Docker ignore file. Here in our app, let's go double check our dependencies. inside the Docker ignore, it looks like those are all of our dependencies. That's perfect. Here in our Docker file, we do that same process from alpine as build. We don't have any Git dependencies in this, so let's remove that one. We'll copy in our manifest. We'll install all our libraries, copy in everything else, build. In this case, we don't need to prune to production because what we're going to copy into place is not this built content. It's a static set. So this is from node alpine, let's say from Nginx alpine, a static web server. Now the static web server already has the CMD built in, so we don't need that here. And the worker for this is actually configured by Nginx. So let's go pop open this one. There it is. There's the work directory. Now this work directory is the spot where Nginx assumes that the static files will be. So now when we copy from build, we don't need node modules. It won't run anything, but we'll copy from source dist into place in this app folder, this app container. We still have our build server doing all the things, but now we have a really, really small static web server hosting our SPA. That's really cool. We're in the API folder, so let's get into the app folder, and docker build-t app v0.1 dot for our current folder that we want to use as that build context, and let's kick off that build. There we go. Copying all of the content, installing all of the dependencies, running the build. Now one thing that we're going to notice here as it does the TypeScript linting is that it's going to have trouble here with this product detail. Here in this product detail, we're assigning a product or undefined into this product variable, and it wasn't able to infer that this should have been a product or undefined, and it's going to say, how do you set a product into undefined? Let's create an interface here that will describe how that works. Interface product detail view, no, product detail model, and it has an ID that is a number. It has an error that is a string. What did I do there? Product detail. Maybe I just haven't saved it right. Oh, interface. Error is a string, and product is a product or undefined. So that's a number. So we've got those things. Now we can just say this is undefined. And we'll say this is as product detail model. Perfect. We don't need this anymore. ID number, errored boolean, and product is undefined. Product errored ID. Let's go copy that. Oh, because it's not, there we go. No, it's grumpy because this part is a string and I'm trying to mount this string into this number. So this isn't a number. Let's call this quote quote, and let's call this string. Okay. As product detail model, I'm gonna go double check this. Copy that into place just in case. I'm guessing I typoed something silly there. ID is a string, error is false, product is undefined. To type product detail model, status is missing. Ah, yes. Status is kind of interesting. So let's say status is 0. Now here, as we're returning this, we can say this.status equals result.status. And if data gets an error, this may not be a product or undefined. So let's say if this.status is less than 300, then that's data. Else this.product equals undefined. And that'll help us in cases where bad things happen there. Now that we've got status, we can pass status into our errored thing. Status equals status. And we should be good to go. Let's reload this and see if TypeScript got the hang of it. Not that one. Ah! No, that one. Did it figure it out? As product detail model. Nope. Well, we'll see in a minute if TypeScript is just being strange. Ah, status. Okay, so now it's good. There we go. That's how we expect. Okay. So there's that error that we got in TypeScript saying that this was unable to define correctly. Now that we've solved that error, let's go rebuild it. Docker build -t app v0.1 and that dot giving it the current folder, that build context. While that's building, let's start firing up content for Kubernetes. Let's create a Kubernetes folder here. I'll create a new root folder, new folder, K8s, and let's go build some YAML files. First up, let's go out to the MemSQL blog, spin up a MemSQL cluster in Kubernetes in 10 minutes. Now the cool part is whether you're using Docker Desktop or another runtime, Docker Desktop allows you to fire up a Kubernetes mode, just go into the settings and turn it on. If you have another Kubernetes environment, that's perfect. Here's that YAML file that will get us to where we need to be. Copy that YAML file. Let's create a new YAML here, memsql.yaml. Now this YAML file includes both the deployment that will spin up our pod, where the container is embedded in it, and the service that will route traffic to it. The service will accept traffic on port 3306 and route it to port 3306 in the container. That's where MemSQL's engine is listening. And 8080 will route to 8080 where MemSQL Studio is. Now this is of type node port. We probably wouldn't expose this publicly outside the cluster in a normal thing. We'd probably flip this to cluster IP. But for our testing, it'll be really nice. We'll have 3306 exposed and 8080 exposed. Except for node ports must be in the range of 30,000 to 32,000, less than 32,000 and 30,000 or greater. So let's hard code this to 3036 and 30,080. Here we have our definition of the deployment in our spec for the container. We identify this as named memsql. It's pulling the memsql cluster in a box image. That's the same image that we used in Docker Compose. And then we can paste our license key here. Well, instead of pasting our license key here, let's do something different. Let's grab a secret. So let's pull this value from a secret. And that way, when we version this file, our secrets won't get exposed to source control. Now we're going to pull it from a secret named memsql license, and the key in that secret will be license key. So let's create a new file, memsql license.yaml, and this memsql license.yaml will include all of the details about our memsql license. So I went to portal.memsql.com. I'll paste in my license key here. And then when we're ready to go, oh, String is not assignable to number. Ooh, I see I did miss one. Product detail view. This is a string, not a number. And now because it's a string, let's put quotes here. And now that should build as expected. First, cd k8s kubectl apply -f memsql-secret or memsql-license and kubectl apply -f memsql.yaml. Now I've done both of those previously, so kubectl get all. We see there's our memsql cluster ready to go. I'm going to go back and rebuild that container. Now that we've fixed that error. And while we've got this memsql cluster ready to go, let's save all the things. We can log into memsql. We can go to localhost 30080 and start to log into our cluster. I'll do localhost. This is container in a box, so root with no password. And now we can take a look at the query editor. I did spin this up previously because it takes a little bit to spin this up. So I've already created the database, initialized the content, and we see here in the database, yep, it's ready to go. Next up, let's start to build the Kubernetes content for our two containers. Now we can start with this. Let's start here. We'll create a new one for api.yaml. And here in api.yaml, copy and paste is nice. Memsql will change to API. And we can pull out a few of the comments that are a little distracting. I'm glad it's defined so well in the blog post. The image will be API v0.1. This API is on port 3000. And now the environment variables. In the Docker file for the environment variables, we specified a lot of these environment variables and gave them default values. Let's do the same thing here. We could choose to pull them from secrets if we need to, but for the sake of simplicity, let's go grab all of those environment variables and just set them in place. Copy paste fail. Copy the selected window. Copy. Paste. Okay. Now in the service, oops, we don't need two different ports. We only need one port. So we don't need a name for this port. We also don't need to hard code the node port. We'll just let it assign one. 3000 goes to 3000. We could dial out this section, this resources section, talking about the limitations of our container, how much CPU or RAM we need. But in this case, we'll just leave it blank. app.yaml. For our app, we'll do a really, really similar thing. Let's find and replace API with app. And the one thing, it's not app version in kind, it's API version in kind. We'll need to do that in both places. And we know that this container runs on port 80, not on port 3000. So let's give it port 80, and it's app v0.1. Perfect. Ooh, that image built successfully. Back in our K8s folder, kubectl apply-f api.yaml. kubectl apply-f app.yaml. kubectl get all. Container creating, perfect. So we've got our API running, we've got our app running, both of them are exposed through services, and we have this node port. Here's the node port for the API. So let's go to localhost to that port, and we'll go to API/product/1, go grab our product. Oh, great, that worked out well. And now let's also go to our app. Here's our app's external port, our app's node port rather. So let's go to localhost (30467), and we'll load our home page. Now this is going to reach out to go get the product at /API/product/1, which doesn't exist. It's on a different port. Well, how do we merge those together? The cool thing is we can use an Ingress controller for that. This Ingress controller allows us to specify paths that redirect to certain services. So let's go grab this here in KDS. We'll create a new file, ingress.yaml, and let's set this in place. Various cloud providers will require annotations that get us to allow setting up DNS in interesting places, but in this case, we'll leave that blank. Now we want to say the API routes go to the service named API on port 3000, and we want to say everything else goes to app on port 80. So now when the browser reaches out from the app into the API on the same host, it will go off to that other container. That's perfect. kubectl apply-f ingress kubectl get all. Now Ingress isn't part of all for some reason, so kubectl get ingress. There's our ingress, and it's running on port 80. That's perfect. So let's head out to localhost port 80. We have our app. We can go to that product detail page, and we see that it did load correctly. That's perfect. And it loaded up our app. That is great. We got our data from the API. The API pulled that in from the database and loaded it up really nicely. Now, our product list is still bare. We'll work on that next week, and our about page is bare. So we'll get to do some interesting things there. So this was really cool. We grabbed we created Docker files and Docker ignore files that allowed us to build our app into containers. We created the Kubernetes YAML files for MemSQL, our SPA app, and our Node API. And we applied those to Kubernetes so that we could get all of our content into pods and services there in Kubernetes. The service routes the traffic into the pod, being a load balancer across all of them. And then we created an Ingress controller, which allows us to direct certain parts of our application to our SPA and certain parts to our backend API. That allowed us to have a single URL that we can use to do both containers, removing the need to create environment variables or CORS headers to be able to communicate between our SPA and our API. Next week, we're going to dial out the product list page, and we'll get some more methods in there too. That'll be really fun. Join us next week at the same time. Thanks.